Hey everyone, lesson 6.3, properties of slope. In lesson 6.2, we talked a little bit about how slope can be calculated from a line or from two given points. So as we take a look here, please refer to your learning targets before you go any further. So a positive slope and negative slope. Slope, remember, is the change in x over the change of y. It's a rate of change. A positive slope, as we talked about in 6.1, a positive rate of change indicates an upward trend, whereas a negative slope or a negative rate of change would indicate a downward trend. With a positive slope, both x and y are a positive change, so your numerator and your denominator are positive. In a negative slope, a negative value would only occur if either the numerator or the denominator was negative or positive. So positive slope means that we've both got positive values in each. A negative slope means either the y or the x would be negative. Left a little space for us to check an example. Let's take a look at this graph here. We've got two different lines, the line P and the line Q. First, we're going to consider the line P by finding two identifiable points, -1, 4, and 2, -2. Let's go ahead and look at our change in y and our change in x. Our change in y, this line appears to be going down 6 as we go over 3. So we've got a -6 change in y and a +3 change in x. So our slope simplifies down to be a -2. Let's go ahead and change that out. There we go, simplifies down to be that -2. And again, we can see that downward trend as the line is going down. Let's take a moment here to consider then line Q as well. Line Q, we've got two identifiable points, one of them being, of course, -3, 0. One of them being, of course, -3, 0 here, and then the other being 4, 3. So we can follow that. We can see that we need to go up 3 and over 7. So we've got a change in y equal to 3, and we've got a change in x equal to 7. This is a positive slope, and we can see that this line would be considered going up. Now, sometimes people say, well, really, depending on which way you're looking at it, either one could go up or down. Generally, we consider trends as we move from left to right. So that's why we would say that this line Q is going up, whereas the line P is going down as we move from left to right. So let's talk a little bit about the zero slope and the undefined slope. Please remember that slope is equal to the change in y over the change in x. The only time that a fraction will zero out and that a slope would become 0 then is if the numerator is a 0, meaning the change in y is a 0. So as we take a look, if we want the change in y to be 0, that means that we want the same y coordinate. If the y coordinate is the same for all points, what we have is the case of a horizontal line. A zero slope would always indicate a horizontal line. Based on our work in chapter 5, as we take a look at the undefined slope, a slope will be undefined if the denominator is a 0. A fraction becomes undefined when a denominator is 0. So if we take a look here, the denominator then would be 0 if the change in x is 0. If your x coordinate is always the same, what we're looking at is a vertical line. An undefined slope always indicates a vertical line. So if we're being asked to graph a line with a given slope, it's actually pretty easy to do. It's just a few different steps. We graph the given point, and then we follow the change in y and the change in x to find another point or more, and then draw the line. So an example of this would be to graph the line through -3, -2 with a slope of 2. So here is a piece of graph paper for us to go ahead and get started. Go ahead, begin, again, graph the given point. Step 1 is to graph the given point. So we've got the point -3, -2 on the graph. Follow the change in y and the change in x in order to find another point. 2 would indicate a 2 over 1, so our change in y is 2, as our change in x is a 1. So we would show going up 2 over 1, and we've got another point. Up 2 over 1, we've got another point. We could keep going, up 2 over 1, or we can see after 3 points that the line would look exactly like this. Could we give the coordinates of another point on this line? Of course. We actually have 2 that we could look at pretty nicely. We've got one at -2, 0. And we've got one at -1. 2. We'll need to adjust that out here. There we go, much better. A little copying, pasting gone awry. So we have two options that we can pick from, -2, 0 or -1, 2. So we talked a little bit about positive slope, negative slope. We've talked a little bit about undefined slope and zero slope. One thing that we're also going to discuss is how does the value of slope affect the line? We know that the positive and negativeness of the slope will change the direction of the line, downward trend or an upward trend. We also need to consider what happens if the slope itself changes. So on the same graph that you did your last example, I'd like you to add 2 other lines. So again, through the point -3, 2, graph a line with a slope of 6, following the same process. And then we're also going to graph the line through the point -3, -2 with a slope of 0.25. It might be handy to know that 0.25 or 25/100 is also the same as 1/4, 1/4. Go ahead and take a moment to graph those on the same graph. We're going to do some comparing here, so we do want to put them on the same graph. So we are going to be doing some comparing. I'd like for you to compare these 3 different lines with the 3 slopes of 2, 6, and 0.25. How do they compare? And be prepared to discuss this with the class.